Okay, so yesterday we talked about the SI measurements, that certain things are supposed to be measured in specific units. We're going to call these the base units, okay? And meter and gram are our base units. Even though kilogram is the accepted unit, gram is the base unit. Later on, we're going to learn about derived units, which is taking these units to make other things. And so sometimes they'll be the base unit. For instance, when we're doing volume, the base unit is a liter, okay? And they mean certain things. But remember yesterday we were talking about scientific notation. I said we're going to use really big numbers and we're going to use really small numbers. And one of the things that we can do to keep from using all the time really big numbers and all the time really small numbers is we put prefixes with our units. And that is the metric prefix system, okay? These are the most common that we're going to use. There's a lot more. Actually, I used to have a chart in the notes. I took it out because people were like, "Do we have to know those?" Because it goes like way more than that. Like there's a yottameter and a yoctometer and all that stuff. You can look those up if you want. They're like 1 times 10 to the negative 20 something. You know, they're huge or they're very small depending on which way you look at it. But these are the most common, and a lot of these you're familiar with. If you know anything about computers, you know about gigabytes, and that's the giga means 1 times 10 to the 9 is a billion. Okay, megahertz for data and stuff like that is a million. So a megahertz is a million hertz. And then kilo, if I said, I'm going to give you your Paul, right? Not Peter, your Paul. So if I say, hey, Paul, I'm going to give you 5K, how much money would I be giving you? 5,000, yeah, because it takes $1,000 to equal a kilo or a K. And then the smaller, so from kilo up, we're going to draw a little line here. These are larger than the base. Than base. And when I say base, that could be liters, meters, grams. And then from deci down is smaller than the base. So if I say centimeters, so how many centimeters does it take to equal a meter? It's 100, because centimeters are smaller. Okay. If I say milliliters, it takes 1,000 milliliters to equal 1 liter because they're much smaller. Okay. And then we can get down into the really, really small, which is nano and pico. And they go even smaller than that, but those are the ones we're going to deal with. Usually when we're talking nanometers, we're talking about wavelengths, the wavelength of light. The wavelength of like colored light is in the nanometer range. And then a picometer is really, really small. And that's what when we're talking picometers, we may be talking about the length of one atom's nuclei to another. It's a picometer. So they're tiny, tiny, tiny. Okay. These are the ones that you should memorize and know. But I will tell you the ones that we will use the most are kilo, centi, and milli. You should memorize them all, but those three for sure, because we use those all the time, and we're going to convert with them all the time. Matter of fact, we're going to convert with the milli and kilo the most, the very, very most. Okay. So it just helps to memorize them. Okay. So that is our prefix system. Now, easier way to calculate. Let me go back one more. These are the way they're defined. They're defined as a centimeter is 1 times 10 to the negative 2 meters. Okay? But for me, my brain works better in whole numbers. It is easier for me to remember that there is 100 centimeters in a meter than in 1 meter is 1 times 10 to the negative 2 meters. Okay? So I encourage you that this is an easier way to remember it. And these are the ones we do use the most often. So we're going to use these as conversion factors, okay? And a conversion factor is something you use to convert one unit to another unit. For instance, if I ask you how many feet are in 82 inches, what would you do? You would use what as your conversion factor? 12 inches in a foot. That's a conversion factor, okay? So if we know that there are 1,000 milliliters in a meter, like in this first one, I can either write that as 1 meter over 1,000 millimeters, or I could write it as 1,000 millimeters over 1 meter, because they are equivalent. Do you understand that? Just like 12 inches is equivalent to 1 foot, or 1 foot is equivalent to 12 inches, right? Doesn't matter which way I say it, they're still equivalent. Okay, so we're going to use them as conversion factors throughout this whole year. And that brings us to dimensional analysis, which is, I even wrote it in red and underlined, the single most valuable mathematical technique in general chemistry, also in physics next year. Okay, unit conversion is the key to success in math problems in here. okay? It's like your roadmap. It's how you get from point A to point B, or C, or D, because sometimes we need to go from A to E, and we're going to go through B, C, and D to get there, okay? So we're going to start with something that we know, which is money, okay? I want to caution you here, and I'm going to say this not sternly but strongly, okay? What we're doing today, you know how to do the easy conversions. And I'm showing you how to do dimensional analysis and the setup that is helpful with things you understand, instead of just jumping right into things you don't know what they're talking about. So I'll start you with the easy stuff. So please refrain from just going, it's easier for just do it in my head, or I don't want to set it up like that. I want to do it as a proportion or a ratio. Please, I implore you to do it the way I'm showing you, because I know what's coming down the pipeline and you don't. I know that we're going to convert grams to moles. Do you know how to do that? No. Is it something you know automatically, like 12 inches in a foot? No. Oftentimes we have to calculate the number that we convert with, okay? And so I'm going to encourage you that even though it seems easier to do it your way, to please bear with me and do it my way. And I will also preface that with, a lot of kids over the years have thought, oh, she doesn't know what she's talking about, it's just easier to do this way. And then they always come around when they get to the harder stuff. So just do yourself a favor and do it like I asked in the beginning. Most things I'm not that strict about, but I'm telling you, for your own benefit, the way that I'm going to show you is going to work in the long run, okay, for you. All right, so let's start with something easy. Now, there are two different ways we can do this setup that I'm going to show you, with a grid and without a grid. Most kids end up liking the grid, but I'll show you without the grid as well, okay? So this is easy. We know how many quarters are in a dollar, right? So I'm going to start always, when I work a problem, always start with what they gave me in the problem, which is $5.85. And it wants to know how many quarters. So I'm going to write $5.85, and then I'm going to do this little grid, and I'm going to say that in every $1 is 4 quarters. Okay? You could also say in $5.85, you could say there are 4 quarters. You can do it as a fraction. They mean the same thing. Anytime I divide anything by itself, what is it? 1. So I am dividing units by themselves. So the units cancel out. The numbers do not. So I'm going to cancel out the dollar signs, because they cancel out. Now that is 2 numbers on top with a 1. So I'm going to multiply. And what do I get? How many quarters? It's not going to be an even number of quarters. Should be 23 quarters and then some left over, right? So it's 23 quarters. So that's we'd have some cents left over. I hope you all have cents. Okay. So whether I set it up the first way or the second way, I'm going to get the same thing. Okay. This grid, when I write that, just basically means times. And if it's on the top, we multiply. If it's on the bottom, we divide. Okay. So we're going to do several more examples, because that's too easy, right? You're like, why is she showing me this?
So we don't write that there's leftovers, we just write.
Well, normally we would, but when we're dealing with something that is a finite quantity, like you cannot split a quarter, then we're just going to keep it as a whole number. Okay. On your barnyard math today, we're dealing with animals, and you're going to round up to the whole number. When we're doing real problems, you're going to report it based on the significant figures, but we're doing that next week. I want to take you through the process. I've done it both ways. I've taught dimensional analysis first and then sig figs, or I've taught sig figs and then dimensional analysis. I've done it both ways. I feel like it works a little bit better for me to teach you the process, and then now that you've got the process down, now let's talk about how we should really report it. So I've flip-flopped both ways. So today, this year, we're going to go with sig figs after dimensional analysis, because honestly, the dimensional analysis is a more important concept than if you report the number incorrectly. Okay. All right. Here's our roadmap. Let's practice this some more. Units matter. Okay. We want to include our units. Don't just write down numbers, because especially when we get to real chemistry with dimensional analysis, you need to be able to follow the process of what you did. Okay. So let's practice another simple one. We're going to convert a 125-pound box into kilograms. We're going to just use the 2.2 here. We're not going to be so... Well, we'll go ahead and keep it in there, I guess. So here's how we would set that up. First of all, we would line up your conversion factors. and set up the problem. So we have 125 pounds, and we would put 2.2046 pounds on the bottom, and then kilograms on the top. So we're going to say cancel, cancel. Those units cancel because I divided it by itself. But please make note, when we cancel units, we do not take away the numbers. We still have to do the math, okay? And then I would get 56.7 kilograms, okay? Does that make sense so far? Please stop me, and if I'm going too fast, please stop me, because I know I talk fast. Okay, then you're going to multiply the top and divide by the bottom. Okay, and then double check that all your units canceled. Okay, and then double check does the answer make sense. Okay, we were dividing 125 by 2 roughly, so we should be in the 50s somewhere. Does that make sense? Yeah, we're probably in the ballpark. Okay, because invariably, and especially y'all's generation, is so calculator dependent that you just plug things in and you trust the number it gave you, right? Well, you had to plug it in correctly. Okay, just because that's what the calculator said it was, doesn't necessarily mean that that's the answer. So you need to just kind of, use some number sense and go, okay, I'm doing 125 and I'm divided by 2, I should be in the 50s. So if I get an answer and I'm in the 80s, well, I did something wrong. Go back and look, okay? But your units are your key. You've got to follow your units. Follow your units, follow your units. I will say that so many times. I've had kids come back from years ago. Just last year, I had a kid that was, I taught way a long time ago, and she decided to go back and go to nursing school. Like, she worked for a while, and she wanted to go to nursing school, and she had to take some exam, and she said, I didn't have time to study it, but she goes, I'm taking it. She goes, and I hear your voice in my head, follow your units. And she did great on the math part because she just said, oh, yeah. And so she could do it, even though she didn't remember how. She just she lined up her units to cancel, and she was able to get what she needed to get. So I hope you hear my voice in your head 10 years from now, too. That makes me laugh. Okay, so let's practice setting this up. Okay, so we're going to do 30 meters to miles. We're going to use these conversion factors up here. We're going to make this easier on ourselves, and we're going to do 1.1 yards instead of 1.094. So let's do it. So we're going to start with 30 miles because that's the only thing we know. So not 30 miles, 30 meters. So we have 30 meters. We want to get rid of meters. So where do we need to put it on the next step? On the bottom. So 1 meter is equal to 1.1 yards. So meters cancel. We're going 2 miles, but we have to get rid of meters first. Well, we can't go directly to miles, can we? No, it's not a conversion factor we have. Now, we could look that up, but these are the conversion factors that are listing for we're going to use these. But there would be a conversion factor. You could ask Siri, hey, Siri, what is it? Whatever. Now we've got yards. We want to get rid of yards, so where do we put yards? On the bottom. And that conversion factor is this one right here. So 1760 yards is equal to 1 mile. Yards canceled. Now we have the unit that we want, so we stop putting things down. Now we multiply the top and we divide by the bottom. Okay? So go forth and conquer that in your calculator. Oh, it's on. And you should get a decimal if you did it correctly. Who wants to give me their answer? Be brave. Come on. Yes? 18.75. 18.75? You're off by a couple of factors of 10. I got 0.01875. Is that what you guys got?
Yes. Wait. I don't know what I did.
Well, you did. I'm not sure what you did just because you got the 18.
Oh, I added 1,760 instead of dividing.
Oh, okay. So you added it. Okay. All right. So that's how you would set that up. Any questions? We're going to do more, but any questions at this point? Do you know why we did what we did? Okay. So now let's do, well, yards to miles is going to be a one-stepper. So we have 1,500 yards. We want to get rid of yards, so it goes on the bottom. So we say 1,760 yards is 1 mile. So we would expect that, we're dividing 1,500 by 1,700, we sort of expect it to be a decimal, but not like a really small decimal. Right? So hopefully you got 0.852. So now let's do this one here. This time we're going to go miles to meters, so exactly the opposite of the first one we did. So we start with 206 miles. We want to get rid of miles, so where does it go? On the bottom. 1 mile is equal to 1760 yards. And then we want to get rid of yards, so we say 1.1 yards is equal to 1 meter. So we multiply the top and divide by what's on the bottom. And you should get a very large number. Someone give me their number. Yes, Raquel.
31,836.363.
I got a different number. Yeah, I got 329,600. Did you use the 1.1 yard or did you use 1.09 for? Yeah. Just put it in. Just try it again. You might have transposed a number. I am the world's worst about transposing numbers, so y'all actually need to check, because I will say the right number and then I'll write down. Yeah, on a number like 1.1, it doesn't matter if I transpose right. I'm so bad at. Yeah, I am really bad about transposing numbers. Okay? Again, are we good so far?
Yes.
So far, so good? Okay. Let's do a couple more examples just so we can get this straight in our brains. I think the next examples are, these are just kind of asking us questions. What would be larger quantity, 3 miles or 3,000 meters? So you just take one of those and convert to the other and so you can compare it. So we're going to do the last one. Do you want to convert kilograms to pounds or pounds to kilograms? What you want to do here? Pounds to kilograms. So 25 pounds. And we said on an earlier slide that it was 2.2 pounds in 1 kilogram. Right? So 25 divided by 2.2 is 11.4 kilograms. So 25 pounds would be a larger quantity. To me, the miles to meter one is pretty easy. Which one's larger, 3 miles or 3 meters? I mean, 3 miles or 3,000. Again, if you converted that, it would be. So now let's actually practice some unit conversions with our metric, because the best way to memorize them is use them over and over. Okay. How many centimeters in a meter? 100. How many milliliters in a liter? 1,000. How many grams in a kilogram? So there's some things that you use in every day that kind of count if you get to a test and you're like, oh my gosh, I can't remember. So think about things you know already with those prefixes. How many years is a century? 100. Centi is 100, right? How many years in a millennium? 1,000. There's milli. How many years in a decade? 10. Deci. And then we already did the 5K. I'm going to give Paul 5K. Not really, Paul. Sorry. I apologize if you don't get 5K. I can't even give you 5K pennies. That's $50, so, you know. If I ever win the lottery, which I don't play, I will give you $50, okay? I'll give you 5K pennies. But I don't play the lottery, so don't hold your breath. Okay, so 42, Mike, that little funny looking U, which will catch you every time. I'm on some examples. Turn the page.
Yeah, we don't have that.
Okay, well then let's just do this.
That first one, but we have the next.
Oh, you don't have the micro?
We have the 2 middle ones. Is that a Greek letter?
It is a Greek letter. It's also a funny looking U with a tail. I don't know. It's called a micro.
It's like,
How many, let's convert 42 to meters. It's a micrometer, okay? So, find a spot on your paper since you don't really have it. It's just practice. So 42, we're going to start with 42 micrometers. Don't worry, you too can make the micro sign. It just takes practice. If you look up that conversion, it is very small. It takes a million, or 1 times 10 to the 6, micrometers to equal 1 meter. And so yesterday, I believe I showed you how to put that into your calculator. There was 1 or 2 classes that we forgot. We got to the end of the class and they're like, why did we get the calculator out? And I was like, it was us?
You didn't show.
Okay. If you look at the calculators, there's a button, and it's between, I think it's right above the cosine button. It says times 10. So you can actually, these calculators actually have a times 10 button.
How do you get that wrong? Can't you just put the calculator inside?
You can, but on these calculators, why would you when there's a button that you know you can't mess up if you hit it? I mean, so we do 42, and then we divide the 1 times 10 to the 6. It should be a small number.
Wait, should I get to the negatives?
It is. I don't. If for some reason on my that's not working.
Wait to the next.
Oh, when you're dividing by that, you're gonna have to put parentheses around it. Otherwise, it's taking the 42 divided by 1 and then multiplying by 10 to the 6. So do 42 divided by open parentheses 1 exponent 6 close parentheses, and now you should get the right answer. If you take it out of the thing, no.
Why is it to the 6 and not the... Oh, because the conversion rate is positive.
So it should be that. That's how many meters are in a micrometer. Okay. If you're having trouble getting that to work correctly in your calculator, hold on and we'll do that after we get done.
Wait, so if it gives you the answer like just in regular decimals, not in scientific, can you just like...
So remember what we said yesterday, really big numbers and really small numbers, we go ahead and put in scientific notation. And anytime you're going to have about more than 3 zeros in front of a number, I say throw it in scientific notation. Because then if I'm having to count your zeros, or you're having to make sure you write enough zeros, it's very easy that if you needed 5 zeros in front, then you put 4 or 6 or whatever, and then you get the answer wrong. Okay? Okay. Let's do this one right here. 49.8 milliliters. How many milliliters in a liter? Milli means?
1,000.
So it's 1,000 milliliters in 1 meter. So 49.8 divided by 1,000. I don't even need to put that in my calculator. I can say it's 0.0498 liters. I changed that. Y'all didn't catch me. I did milliliters to meter on an accident. There. Y'all are supposed to catch my mistakes nicely. Just like I'll catch your mistakes nicely. Okay? And then we'll do the last one, 33.9 picometers. A picometer is 1 times 10 to the 12. Picometers is 1 meter. So if you're looking at that first conversion chart, so I heard someone say negative 12. That's how many meters are in 1 picometer. I do it opposite. I keep them as a positive. And I'll talk about that. So you can either say in 1 meter is equal to 1 times 10 to the 12 picometers. Okay? Because it takes a lot of picometers, a trillion of them, to equal 1 meter. Okay? It is a lot because they're teeny, teeny, tiny. You can't see that. I mean, it's too small to see, obviously. Yeah. Yeah. Okay? And so that should end up being 3.39 times 10 to the negative 11 meters. Okay. Does everybody have that? Because I'm going to erase it and kind of clarify something. Okay. Erase all strokes, and then let's add this. Okay, so if you were looking at that chart, the way that these things are defined it says that, so there's two ways to look at this. So I can say that 1 meter is equal to 1 times 10 to the 12 picometers. Okay? Conversely, I can say that 1 times 10 to the negative 12 meter is equal to 1 picometer. Just depends on which way you look at it. Do you understand that that's inherently the same thing? Okay? But personally, I think this is easier to remember. I like to keep the 1 for the things that are smaller than the base unit. I like to keep the 1 with the base unit. Again, same thing when we talked about centimeters. We can say that 1 meter is equal to 100 centimeters, or we can say 0.001 meters is equal to 1 centimeters. Which way is easier to remember? First or second? Yeah. Okay, so if you're looking at that chart, because I have to show you the way that they're defined. That is the way they're defined. But in order to utilize them, to me, this is an easier way to utilize. This is an easier way to utilize. If you like the other way, more power to you. You can use it. But I will always keep those as positive, the exponents. It's easier for me to remember. It's easier for me to think, boy, picometers are really, really small, so it takes a lot of them to equal 1 of my base unit. Okay? It's usually easier for students as well. Okay? All right. And let's convert this one, real world stuff. Your heart pumps 2,000 gallons of blood per day. How long in years would your heart have been pumping if it pumped 1.5 million gallons of blood? And I want you to work this out and see if you get it. I'm not going to work it. I'm going to pause the video while y'all work that. Okay, so the way that you would set that up is you would start with what they gave you in the problem. It's this one right here. So 1,500,000 gallons. Okay, and it's telling you that your heart pumps 2,000 gallons per day, right? How many days are in a year? 365, unless it's leap year. Day per 1 year. So now you multiply the top, which is 1.5 million because it's 1 and 1, and then you would divide by 2,000 times 365. So you would get, I would round that to 2.1 just because y'all don't know about sig figs yet. So I got 2.1, but 2.05 is what you got, Michael, would be the same thing as 2.1. Okay? So before we stop the lecture for the day, I want to do the first example problem for the barnyard math. Okay? Using the conversion factors. Okay? Is everybody good with that? The blood? Okay? That's a lot of blood your heart's pumping in a year and a half, 2 years. Okay. So the first problem on your worksheet for barnyard math is you have all these conversion factors, okay? And this is where I'm going to tell you, I know a lot of you probably want to just do proportions and don't, but please, we're practicing a process. I know what's coming down the pipeline and how we're going to set problems up, and you're not sure what's coming down the pipeline. So trust me. Have I given you a reason not to trust me yet? No. Like Neelish said, throwing out the ambiguous problem built the trust factor. So continue to trust me until I give you a reason not to. I have your best interest at heart. So the first question asks how much corn is needed to buy 2 horses. So we can only start with what? The only thing we know. 2 horses. You can't start with corn. That's what you're trying to get to. Okay? So we're going to start with the 2 horses. You can abbreviate here. Don't write out all these things. So 2H for 2 horses. Okay? We are going to kind of, before we set the problem up, we're going to work a little bit backwards. We're ultimately trying to get to corn. So we're going to look at our conversion factors and say the only conversion factor with corn is a cat. And then I see that I could get cat for dogs. And then for horses, I could either get dogs or I could get cows. Well, it looks easier for me just to go straight to dogs because I can go dogs to cats then. So for every 1 horse, I get 8 dogs, right? Then for every 2 dogs, I get 5 cats, which just proves that dogs are worth more than cats. Sorry, my cat lovers. I love cats too, but I love dogs more. And then I can go 1 cat is equal to 20 pounds of corn. So I cancel all the units, and I stop when I get to the unit I'm looking for, okay? So now I multiply the top, and I divide by the bottom. So multiply the top and divide by the bottom, and tell me what you get.
800 pounds.
How much?
800 pounds.
That's what I got.
400.
That's what I got.
I got 800.
Yeah, I
I got 800.
Yeah.
I also got 800. So you get.
Oh, I thought you were taking a long pause because we were wrong.
I was taking a long pause because I couldn't remember. So that would be my answer. Okay? On this worksheet, round to whole numbers. Okay? Because if you're a farmer, do you want half a cat? No, you do not. Okay? So I'm going to stop the video there.